Hey dev friends, welcome to a new series called Airship Object-Oriented Programming, where I'm going to help you understand the fundamentals of programming from the beginner perspective, and I'll show you it using Airship. So first of all, what is programming? Programming is when you write out instructions for the computer to tell it what to do. In any video game, in any app, someone told the computer how to operate, what to do when inputs are received, and what to display on the screen. To show you a small example, here's code for moving a box around in Airship. So on an update loop, meaning every time we're rendering to the screen, we are saying if the left arrow key is down, then we're going to move in the X direction negatively by our move speed. So left arrow down, move to the left. If the right arrow key is down, move to the right. And the computer will just go down each instruction performing the operations. So writing code is a lot like writing a recipe for someone. If you're going to write a peanut butter and jelly recipe, you would have a linear set of instructions that somebody could follow to get the output that you wanted. The nice thing about humans is that they can infer. So you could say something as simple as grab 2 pieces of bread, spread jelly, spread nut butter, put them together, and you get to eat it. But a computer cannot infer all of the in-between steps of that. A recipe for a computer might look more like this. Take a piece of bread out of the wrapper, set the bread on the cutting board, repeat that last 2 actions to get the second piece of bread, pick up the jelly, open the lid, pick up the knife, put the knife in the jelly, etc., etc. With a computer, you have to be very explicit. You have to say exactly what you want, when you want it. So our goal with this tutorial is we're going to write an application that tracks the stats of dogs and displays them to the user. So this is called pseudocode, when we write out what we want to have happen even when we don't know the exact programming language for it. So what we're going to try to do is we're going to make a dog. That dog is going to have a set weight and age. The dog's stats are going to be able to update. So when the dog has a birthday, its age will increase. And the dog's stats will be printed to the screen. To be able to do this, we're going to need to understand some fundamentals of programming: variables, functions and methods, and classes. So before we dive into first things first, we need to do what all programmers do, which is write a hello world print function. Let's open up Unity and write our first script. If you open up the template project, go ahead and make a folder for this tutorial. And you're going to right-click on the folder, hit Create, Airship, TypeScript file. This just creates a new TS file, which is what Airship uses. And I'm going to call this my first game. Great. To be able to edit these files, I suggest opening VS Code, going to File, Open Folder, navigate to your Unity project, click on the Assets folder. That's where all of your code is going to live, and hit Select Folder. This should open up your project so that you properly get code hints and can open your files. So if I double click on my first game now, it will open up in this project. I can also do Control P and search for my first game to open it up that way. When you make a new Airship script, It comes with some default code, but you can delete it We're not going to use that right now. The first thing we're going to do is write print, which is a built-in function. And we're going to do quotes, hello world. And then you end your commands with a semicolon. So print is a function that writes something to the console. And quotes specifies this is a string, which is just words. So we're passing words into this function, and it will display in the Unity console, just like all these other messages display. So if I play, you might expect those words to show up in the console. But there is a problem. This code that we made just exists on your hard drive. If you show it in the Explorer, it's just a file on your computer. Nothing will get run unless something tells it to run. So in Unity, that means you need to have your script in the scene that is loaded for it to run. So my scene right now is this airship programming scene. I just took a template project and removed the things that I didn't need. I'm going to hit create, right click, hit create empty. This is going to be my game logic. And I'm just going to use this game object to run the script that we made. So if you hit add component and you type luau script, this is just a helper component that will run the code. So if I drag our script into here, again, you grab it from the project, drag it onto this component. You can see that this component now is pointing to the airship script we made. I'm going to save, and I'm going to play. And you can see a printed message, hello world. So if you got that, there's your first bit of code in Airship Unity. Congratulations. Let's see what else we can do. Let's change hello world to program started so that we know when this code is running. In any programming language, there's going to be some default behavior that you can use, such as being able to do math. So let's just add two numbers, 5 plus 6, inside this print statement. What will happen is that the code inside the print statement will happen first, 5 plus 6. Then that will be passed into the print message, and it should print the answer. So I'm going to restart the game. There you go. Program started 11. So doing math is great, but in most cases we're not going to have known numbers that we want to manipulate. We're going to have changing numbers that change depending on what the user is doing in the game. And these are called variables. Variables are stored in memory and change over time. And it looks like this. If I make a variable called my number and tell it to be a number that equals 5, this will be equivalent to what we had before. And if I say let other number equal 6, this again will be equivalent. So let's dive into what these words mean. You can see that these words are colored. That's because they're built into the programming language, as opposed to words that can be whatever you want. So this variable name, my number, can be anything you want. You can't do spaces though, because spaces will break the compiler. So anything you want except spaces and special characters. These colored words are keywords. Let means let's make a new variable. Number is specifying the type of variable you want. There are built-in types for you. So some text message could be a string. A string is just going to be a sequence of characters. This is a string. And there are more complicated ones like making arrays of things, like a sequence of things, or a map that has key value pairs. But that's all stuff we will get into later. For this tutorial, we're just going to use numbers and strings. Oh, another basic one that I will just show you is called a Boolean. And a Boolean just holds a true or false value. Okay. So what is the point of storing things into these variables instead of just typing the numbers? Well, these variables can change over time. So if I do my number equals 7, now I've overwrote this variable to be 7 instead of 5. If I did my number equals my number plus 1, we've now told this number to increase by 1. Let's print out just my number and see if you can anticipate what it's going to print. 8. So why 8? We started at 5, but then we forced it to be 7, and then we increased by 1. So 8 is your final value. Increasing by 1 is such a common functionality that there's actually a shortcut for it. If you do my number plus, you're saying, I just want my number to increase by 1. There's also a shortcut for adding to your number. If I do plus equals 1, I'm saying I want to add 1 to this number. And you can change its value to be whatever you want. I want to add 11. Same works with subtraction and multiplication. So these are basic math operations that you can do on numbers. But let's say that you wanted to add a number every time that the user jumped. So whenever the character jumps, I want to add 1 to the number. Well, you can't just handwrite this, anticipating every jump. You have to run this code specifically when something else happens. We do that by storing our code inside of a function. A function is a group of code. For example, when you run this print function, you are running a group of code that does something. In this case, writes to the console. So we're going to write our own function that can change our numbers. So let's make a function. I'm going to call it add number. And you're going to pass in the original number, which is of type number. And you're passing how much to add. Adding amount, which is also a number. So what we're saying here is we're making a new function. We're giving it a name, which can be whatever you want. Inside the parentheses, you can specify what variables are going to be passed in. These are called parameters. We're saying the name of the first parameter. We use the colon to say it's going to be of this type. It could be a Boolean, it could be a string, but we are just working with numbers. Comma says that we're going to have another parameter, which is the adding amount. we're going to take the original number and we're going to add it with the adding amount. To get this number back into our code, you use a keyword called return. So we're saying open bracket in this block of code, which is the function, we're going to add the values, and we're going to return that value to whoever called this function. And that will make more sense when we use it. So if we make a number, let's say 5, and we want my number to equal add number my number 10. This is going to run the function add number. Inside the parentheses, you pass in the variables, just like how you specified what parameters it needs. So in this case, I'm passing the variable my number into the first parameter and 10 into the second parameter. It's going to run this code. It's going to return that amount. And since I'm setting my number to equal that, my number will now equal that value. So let's run this, and since we're printing my number, we should see 5 plus 10. Program started, 15. Perfect. And because this value just gets returned, you could do something like this. My number plus add number, instead of storing it back. So now instead of storing it back into our variable, we are taking that returned value and just printing it to the screen. So here I have a string, which is just whatever text you want, and I'm adding the returned value. When you add a string with a number, the number will automatically get converted into a string. So this is called concatenation when you add strings together. And just to show you what that looks like, if I say my first string plus my second string, even though these aren't numbers that you would typically think of adding, it will connect the two strings together for you. So in this case, we would get the same value of 15 showing in this print. Great, so that is variables and functions. So now we're going to get into classes and members. Our goal, if you remember, is to track dog's stats. So we're going to need to make objects that hold the dog's values. So what we could do is say my dog's age equals 7. My dog's weight equals 75. And store each value individually. But what if you have 10 dogs? Now you're tracking all of these things individually, and you have to manipulate them individually every time you want to do something. This gets messy very fast. And that is where object-oriented programming comes in. Object-oriented programming is just the fundamentals of using instance objects in your game. So rather than tracking things linearly, we will create a dog object that we can manipulate. Let's see what that looks like. Up at the top, we're going to say class dog open bracket. Open bracket just specifies a block of code. It's like a group. So just like in a function where we group code, where in a class we group code, but it's used a little differently. So our dog with a class can have its own variables. So I'm going to say age, which is a number, weight, which is a number, and for fun we'll say breed, which is a string, just to show you how you can get more information in there. So now we have a class that has its own variables within it. So rather than having to make new variables for each dog, we can actually just make a variable for a specific dog. So if I say my dog, now rather than saying a number or a built-in type, we can actually use our class as the type, my dog. The dog doesn't get created automatically when it's a class. So you actually have to specify that we want a new dog. So my dog equals a new dog. If I print dog's age, I can now say my dog dot age. This object holds all of the information we specified in the class. Let's print that to make sure it still works. Program started, dog's age 7. So why 7? We specified here that the default value for the age is 7. But we can actually set that number in a more convenient way. We could say my dog.age equals whatever age this dog is. But an even cleaner way is to create a constructor where you could pass in the dog's age as you make the new object. To support that, you use something called a constructor. Constructor just means the function that is run when you create this object. So I'm going to let someone pass in the initial age, and I'm going to set this object's age to equal the initial age. So now when I create a new dog, its age will be 12. If I create another dog and make its age 2, it's a puppy, we'll say my dog and other dog. Let's see what happens. My dog is 12, the other dog is 2. Great, it's using those values and setting it into the age variable. Great. You may notice that concatenating all these strings can get confusing to manage the quotes and the pluses and make sure it all looks correct. So there's actually a better way to concatenate strings with variables. So instead of adding everything, we're actually going to use the backtick, not the single quote, but the backtick, and say my dog. And we can actually add variables into this string directly now by doing money symbol, open bracket, my dog dot age, other dog, money symbol, open bracket, other dog dot age. This lets you add variables directly into the string so that you can get a better sense of what it's going to look like. So these two lines are equivalent. They're going to print out the same thing. Except, oh, like, see, I even forgot the comma there. So I will comment this out. Another useful tip, 2 slashes is called a comment, and it tells the compiler, we don't actually want to use this code. It's just here for the developer. You can use this to help you and others understand your code. So you can say things like, create the dogs, and output the values. If you ever want to keep track of what each section of code is doing. So last thing we're going to do is we're going to add a method to our class so that the dog can get older. So we're going to say have birthday and what happens when they have a birthday? Well, their age increments by 1. And remember, the plus plus is just a shortcut for this. This dog's age is going to equal this dog's age plus 1. So every time they have a birthday, they get 1 year older. So if I print dog's age, my dog dot age, and then make them have a birthday, my dog's new age, we will see their age increment because we called this method on the dog. Methods are just functions connected to an object. So we have a dog object and we are running code on it, so it's a method that updates its own variable. And it's important to note that updating the variable on my dog does not change anything about the other dog. The program started. My dog's age is 12. After its birthday, my dog's age is 13. My dog's age is 13 and the other dog is still 2. Being able to manipulate variables, create functions, and manage classes will get you very far in programming. So it's an important foundation to understand. So even though this code may not look exciting, it's an important first step into your programming journey. And in our next tutorial, you'll get to actually apply this code into the Unity scene to make 3D objects move and interact based on the player. So subscribe if you want to see more tutorials, and thanks for watching.